Section 7.1, example 1, graphing parametrically defined curves. Sketch the curves described by the following parametric equations. So with each of these, let's take a look at this first one. This is going to be our x, this is going to be our y. So if you think of like a coordinate point, x, y, x is coming from t at that specific time, y is coming from or x is coming from x of t at that specific time, y is coming from y of t at that specific time. So to graph these, let's go back to when we were like in college algebra or like intermediate algebra. I'm not sure what they call it in high school, but let's make like a little tree, an XY tree. But here we're going to have t our input, our output for x of t, and then our output for y of t. And if we look here, t goes from -3 to 2. So just to make it a little simple, I'm just going to go, I'm going to use whole integers. So -3, -2, -1, 0, 1, and 2. And that's going to cover all of the values that we're looking at here. And here we're going to input -3 to x of t. So -3 minus 1 is going to be -4. And let's do all of x's first. -2, when we input -2 minus 1 is going to be -3. -1, -1 minus 1 is going to be -2. 0 is going to give us -1. 1 is going to give us 0. 2 is going to give us 1. So that's all of the x of t done. So we could kind of put this one to the side, and now we're going to concentrate on y of t and fill this part out of our table. So -3, 2 times -3 is -6, plus 4 is going to be -2. And then same thing here, -2. So 2 times -2 plus 4 is going to give us 0. -1, so -2 plus 4 is going to give us +2. 0 is going to give us 4. 1 is going to give us 6. 2 is going to give us 8. And now we could see our coordinates here. So this is our coordinate, -4, -2. Over here we have -3, 0. When x is -2, y is 2. And these are going to be the points that we graph. So let's see here. This. And let's start here at t equals -3. This is what we're going to label this point as. We're at -4, -2. So when x is -4, yeah, let's graph it this way. So when x is -4, so 1, 2, 3, 4. Y is -2. 1, 2. So that's our very first point. The next one we have is x is -3, y is 0. There's this point, -2, y is 2. -1, y is 4. 0, y is 6. And 1, y is 8. So notice this was when t is equal to -3. Up here we have t equal to +2. We go straight this way. There's also an orientation, so values were going in this direction as we kept going. And there we go. This is what these parametric equations came up with. So they came up with this graph right here. Let's try for part B. And same thing for part B, we're going to come up with a tree. So t, x of t, and then y of t. T starts off at -2 and goes all the way to 3. So -2, -1, 0, 1, 2, and 3. For x, we have -2 squared is 4, minus 3 is 1. -1 squared is 1, minus 3 is -2. 0 minus 3 is 0. 1 squared minus 3, -2. 2 is 1. 3 is 6. And now for y of t, we have -4 plus 1 is -3. -2 plus 1 is -1. 0 is 1. 1 is 3. 2 is 5. 3 is 7. So we have each of these done. Now let's see what this looks like. X coordinates going from -2 all the way up to 6. Oh, and it looks like these are negative. No, I lied. Okay, so going from -2 up to 6 and then up to 7. So -1, -2. All right, so when x is 1, y is -3. So 1, 2, 3. This is t equals -2. And moving on from there, we have -2, -1, and 0, 1. When x is 0, y is 1. -2, 3. I see the mistake. Okay, so it was right here. When x is 0, y is -3, not 0. There we go. All right, so when x is -3, y is 1. We could get rid of this point here. And -2, y is 1, 2, 3. Perfect. And then 1, we're at 5. 1, 2, 3, 4, 5. And at 6, we're at 7. 1, 2, 3, 4, 5, 6. We're at 7. 2, 4, 6, and 7. And this was our t equals 3. So we started off at this point here, and it looks like we came this way and back up this way. No, kind of. So here we go. And we went in this direction. I'll do it in a different color so we could see it a little bit better. And there we go. There's our parametric equation here. Now it looks like we don't have much room here, so let's just take this to another page. All right. So same thing applies here. We're going to look at all of our different t values and x and y. So t, x evaluated at t, y evaluated at t. And for this one, since we're going all the way up to 2t, there aren't really integers that we could use here. So we're going to use like our radian values. So let's do pi over 6, 2 pi over 6, which is pi over 3, 3 pi over 6, which is pi over 2, 4 pi over 6, which is 2 pi over 3, 5 pi over 6, 6 pi over 6, which is just pi, 7 pi over 6, 8 pi over 6, which is 4 pi thirds, 9 pi over 6, which is 3 pi halves, 10 pi over 6, which is 5 pi thirds, 11 pi over 6, 12 pi over 6, which completes our rotation, 2 pi. That's a lot, but it'll give us an idea of what we have here. All right, so when we plug pi over 6, we have 4 cosine, can always erase this. So we have 4 cosine of pi over 6, which that gives us, let's get our little unit circle up here. Pi over 6 is here, cosine is 2 or root 3 over 2. So we have 4 times root 3 over 2, which gives us 2 root 3. Oh, I lied. We should have started with 0, but we could start here. Actually, no, we can't. So 0, cosine of 0 is 1. 1 times 4 is 1. And here we have our 2 root 3. And next, let's do pi thirds. So pi over 3 is going to be this value up here. Cosine is 1/2. So that's going to be 2. Pi halves up here, we're at 0. And then we have 2 pi over 3 over here. Cosine is negative 1/2. So this is going to be negative 2. Cosine 5 pi over 6 is over here, which gives us a negative root 3 over 2, which is negative 2 root 3. Pi over here is going to be negative 1, so making this negative 4. And let's see what else. Seven pi over 6 is going to be here. It's still negative, so that's still going to be negative 2 root 3. 4 pi over 3 is going to be down here, which makes this negative 1/2 or negative 2. 3 pi, that's going to be 0. 3 pi over 2 is going to be 0. 5 pi thirds. 5 pi thirds is going to be 10. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So 10 is going to be half. So that's going to be a positive 2. 11 is going to be here. Root 3 over 2, or 2 root 3, and 2 pi is going to be 4. All right, starting off here, we now have 4 sine of t. So 4 sine of 0 is going to be 0. And here we're going to be half, so that's 2. This is going to be 2 root 3. This is going to be 4. This is going to be a 2 root 3 again. 2 at pi over here, we're at 0. And we start hitting to the negatives. So from 0, we have 2. And now negative 2 root 3, negative 4, negative 2 root 3, 2, and back to 0. Now that we have that, let's start graphing it. All right, going out 4 units in either direction. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, and 4. So this is our very first spot. So 0, or when x is 1, y is 0. So we're starting off right here. That's at t equals 0. And we could kind of see that these are all of radius. This ends up being like a full circle with radius 4. Let's just do the hot parts. Actually, this should have been 4, not 1. And here we have 0, 4. When x is 0, y is 4. When x is negative 4, y is 0. And down here, no. 0, 4. And we're back over here for t equals 2 pi. This ends up being a circle. And we started here and started moving in this direction. So we could put little arrows going in this direction. And there we go. That's it. If you have any questions, please feel free to ask. Otherwise, bye.